Hey everybody, it's Craig Maynard again, and I'd like to speak to you guys about the SHARP infrared forward-facing sensor. This little baby right here. They're usually around $10 or so in most places. You can get them from my little store as well, and they are so easy to hook up to the system. They have a infrared transmitter and receiver in the front, so it can detect ranges anywhere from about 50-60 centimeters all the way right up close to the robot. So to wire these up, all you have to do is take the red lead and put it into 5 volts. The black lead goes to 0 volts, you can see right here. And the yellow lead, which is the analog signal that comes out, goes into PC4. We're going to put it into PC4 on our robots. Now, you can see I've actually got mine going into a little hole here on the circuit board and going around the back and then coming out at the top right here and then into those ports we just described. Okay. So my sensor's already installed on here, and when I run the program, it looks just like this. The robot would start in the middle with its 5-second sumo delay, of course, and then go into a slow spin. And as it's spinning, it's scanning with its infrared sensor. When another robot shows up in the range, my robot will then go forward as fast as it can. I got it going 200% forward, and then back off and go into another spin routine. So this gives your sumo robot a real competitive advantage over an otherwise blind robot. So how do we do something like that? Well, the code is very simple. We're going to include the samurai.h header as usual, and we're going to set our speed and our this is the set point for the infrared down-facing sensors, the edge sensors. We're going to introduce a new variable called rangefinder, which will be the value held from the rangefinder itself. And then we're going to put a threshold for the rangefinder we'll call range. And I've set it for 300 here. Approximately 15 centimeters is 200. 300 is about 10 centimeters. 400 is about 7. 500 is about 4. So the larger the number, the closer the range is. Okay, and we're going to take our new input, PC4, and define it as an input. That's our analog input port C4. And we're going to have our little 5-second delay, which is standard for all sumo contests. And here's we're going to read, in addition to the right eye, left eye, and mid eye for our sensors, down-facing sensors. We're going to read in the rangefinder. The rangefinder is an analog read in from PC4. Now, if the rangefinder is greater than the range that we defined up above, then we'll do a fast forward, a charge. If the rangefinder is less than range, we'll spin left. And these ones right here are looking at the left and the right eye. If the right eye is less than set point, which is the down-facing sensor on the right side, or this symbol here means or, those are the 2 vertical pipes, or if the left eye is less than the set point, then we're going to go backwards for 2 seconds, we're going to spin right for about 1 second, and then we're going to go back into our rotating scanning mode. So it's a very easy program to write, and it's a very effective little routine for your sumo robots. So I really encourage you guys to, if you get one of these range finding sensors, to put it on. You can use it for all kinds of things, but for sumo, it's the bomb. So I hope this helps you out, and I'd like to see how your robot looks.